So today, what we'll be doing is we'll be talking about a thing called present value of an annuity. But the first thing that we should do is we should make up a cheat sheet for our testing. Okay. Now, remember we started with simple interest, and we had I was equal to PRT, and then we used our triangle to go and create all of these different equations for our simple interest. Okay, now the next thing that we did was we computed the compound interest. Now, compound interest is nothing more than an exponential equation where we have a is equal to p1 plus I to the n, where a is the amount at the end, principal is the starting value, and I is the interest rate. And remember, our interest rate is the rate divided by the compounding periods, right? And then n is the number of compounding periods, which is really just the years times the compounding number. Okay? Now, remember, the compounding number is defined by this table that we have here. A year is 1, semi-annual happens twice a year, quarterly happens 4 times a year, monthly is 12, weekly is 52, and daily is 365. Now, all of these things are used with all of our calculations for the amount of an annuity. Now, let's just do a quick warm-up. We'll do 2 quick warm-ups, and then we'll move on to the main concept for today. Now, you'll notice that we have all of these different problems here, but I think what we'll do is there's 4 problems that I have, but I think we're going to stop at just 2 of them. Okay? Now, let's begin by doing the first problem. Okay? Take a look at this problem, pause the video, then come up with the answer using our apron method. Okay? Alright, since you've paused, let's go through it. So, we have $5,000 invested for 10 years at 3% compounded semi-annually. So we want to know how much money we have. So P is 500 because we started with it. The R in apron is 0.03. The I is 0.3 divided by 2. And the N is 10 times 2. So all we do is substitute all of that into our equation, and we end up with this. So pause the video, check your work, see if you get that. If you don't get it, make sure you speak to me about it. Let's do question number 2. So now, we're going to use our apron again for this one. So, A we don't know, because that's what we want at the end, but we do know that our principal that we have is going to be $15,250. The R value is 5.2 divided by 100. Then we take that 0.52 and divide it by 4 because it's compounded quarterly. And now we just substitute all that information into our equation. And we just got to basically use our calculator to do those final calculations. Punch that totally in, right? And you'll notice that since it's 6 years, it's 6 times 4 is 24. Punch your equation in, and you're done. All right. So let's move on to our new lesson for the day. So for this next lesson, we're going to talk about this thing called present value. The present value of an investment is the amount of money that we start with when we know how much we want at the end of our investment. So we're more concerned about how much money we have at the end than what we have at the beginning. And in this case, what we start off with is P is equal to A, 1 plus I to the negative n. Now, think of our original equation, right? It was A is equal to P, 1 plus I to the n. Think of the A value as the final amount that we have. And that negative n is, hey man, if I know how much I've got, and I know how much time we're going to have it sitting in our account, this negative n goes back in time and brings it back to the original amount. Okay? So in this case, we say P is the present value and A is the amount of money in the future, right? I is the interest rate compounded per period, and n is the number of compounding periods. Okay? You got to remember that when you're dealing with this stuff, right? Remember when we did a is equal to p1 plus I to the n, the number always had to be bigger in the end. This time, the number has to be smaller in the end because we're looking for what we have as our starting amount. Okay, so we always end up with something less than the original amount that we start. Now, so for this problem here, it says calculate the present value of these following. We're still going to use our apron method, right? But we need to basically just fill it out exactly as we think, all right? So it says 2,000 is needed in 5 years compounded annually, okay? So in this case, A is 2,000, P is a question mark, the rate is 8%, so we go 0.08, and then because it's compounded annually, we only have to divide by 1. And it says 5 years, so we're going to have n is 5 times 1, which is 5. And now, all we got to do is set it up in our equation, do the calculation, and we're done. That's it. You'll notice that I have 0.08 divided by 1 in my little calculation there. It's because our interest was calculated annually. So now let's take a look at this next one. We have $15,000 needed in 8 years, compounded quarterly. So $1,500 compounded quarterly. So 1,500, P is question, R is 0.04, but then we have to divide that by 4 because it's quarterly. But then it's 8 years, and we have to take the 8 and multiply by the 4 to get 32. Now, all we have to do now is use our equation. Now, remember, our equation is this. And now we're just going to substitute directly in. And now, you'll notice we do our calculations like we did before, and that's it, okay? Now, you can pause the video and go back and look at the previous calculations. Now, this next one is $5,500 in 3 years at 6% compounded semi-annually. So you know that 6%, if you're not sure of it, is just 6 divided by 100, which is 0.06. Now, semi-annual is, I guess, every 2 times in a year. So we're going to go and have 0.06, and we're going to divide it by 2. Now, the number of years in this problem is 3 years. 3 years. So we have 3 years, but now instead of dividing by 2, we're going to times it by 2. So 3 times 2 is 6, and now we just substitute into our equation like we did before. And we follow the same pattern that we did in the previous section. That's why we're going so fast. Okay? And now we end up with this as our final solution. Okay? Now, let's move on to the next page. So this is a more complex problem. So a loan of $10,000 is due 5 years from now. If the interest is charged at 6.8% compounded monthly, what is the value? So A is 1,000. P is a question mark. R is 0.068. And if you're not sure how to do that, just go 6.8 divided by 100. Okay? Now, you're going to take your I value. So you're going to take the 0.68 and just divide it by 12. Do not compute that. It's always hard to get the decimals right. So just leave it as 0.68 divided by 2. And then we have 5 years, and then 5 is going to be multiplied by 12. And we just punch it in exactly as you see here. And we get 7,124. Now, all I want you to do right now is just take a little bit of time and make sure that your work matches this. Make sure that you can do the calculations on this. If you're having issues, make sure you use the Desmos.com scientific calculator to help you do this. It'll make your calculations a lot easier. All right. Now, have a nice day. Good luck with the homework.